I will be explaining today. You'll be understanding. So today I will help you understand the binary coded decimal. So these are the definition and the basis of BCD. So BCD is actually a digital encoding method where each decimal digit is represented by its own binary sequence, so which allow for very straightforward conversion between binary and decimal systems while facilitating easier human readability. So as you can see on the right hand side of the slide, this is the decimal and the binary conversion. So how BCD represents decimal digits. So first one is individual digit encoding. So each decimal digit from 0 to 9 is represented by a unique 4-bit binary code, which ensures precise representation of numerical values in the digital system. Number two is the ease of conversion. So BCD allows for very simple conversion between binary and decimal formats, so which is very advantageous for applications requiring like frequent human interaction with numerical data. So third one is error detection capability. So the structure of BCD facilitates error detection in digital systems, as the deviations from expected binary patterns can be easily identified and corrected. So these are the importance of having BCD in digital systems. The first one is precision in financial transactions. So BCD ensures accurate representation of monetary values, which is very crucial for financial applications where rounding errors can lead to significant discrepancies in the calculations. Second is reliability in timekeeping devices. So digital clocks and timers will utilize BCD for very precise time representations, which ensure the synchronization and accuracy in various applications, including navigations and scheduling. So the last one is error minimization in a critical system. So BCD exact representation of number reduces the error rate in mission critical applications, such as the aerospace and healthcare, where precision is precision is essential for safety and performance. So this one's comparison with the other number systems. So BCD is a unique encoding of each decimal digit, which allow for precise decimal representation, making it preferable in applications like financial computing, where accuracy is critical, unlike the pure binary system. So while hexadecimal offers compactness for larger values, the BCD provides extreme clarity in decimal digit management, which is essential for application that requires exact decimal calculations, such as accounting and digital displays. So moving on, I'm going to talk about the advantages of using BCD. So the first one is precision in decimal calculations. So it, by accomplishing this, so it will enhance the accuracy in operations, standardized data exchange, and also mitigation of floating point issues. So the BCD maintains the exact representation of decimal numbers, which reduce the rounding errors during arithmetic operations, which is crucial in the application that require very high precision, such as the finance. So standardized data exchange, digital system can ensure consistent representation of the decimal values, which minimize the interpretational discrepancies and enhancing interval availability between devices that utilize different numerical formats. So last one is the mitigation of floating point issues. So BCD effectively prevents the common pitfalls associated with the floating point arithmetic, such as the truncation and loss of significance, so which ensures reliable calculations in complex mathematical and financial modules. So the benefits in financial applications. So first one is so the so to continue. These the benefits of financial application, which is the accuracy in financial reporting. So BCD can help with the have a no BCD have a very precise representation of decimal values which eliminate the rounding errors, ensuring that financial reports and transactions are accurate, which is essential for compliance with regulatory standards and maintaining the stakeholder trust. So this one is error reduction in floating point arithmetic. So number one is precise maintenance, error propagation control, and financial accuracy assurance. So enhanced accuracy in digital displays. So it can be done by as what I've mentioned earlier, which is the precision in numerical representation, and always the user-friendly data interaction, which present numbers in a familiar decimal formats. So BCD help to enhance the readability and reduces the cognitive load for the users. So which foster confidence in data interpretation and decision-making processes. So the last one I'm going to explain is the applications of BCD in real-world systems. So the use in digital clocks and timers. So the first one is precision time representations. So BCD allows the digital clocks to represent time accurately, ensuring that decimal each decimal digit is distinctly encoded, which minimize the error during time calculations and display. So another one is user-friendly display format, which BCD formats aligned with human readable decimal values, so in making it easier for users to interpret time displayed on digital clocks and timers without confusion. So the last one is efficient time calculations. So by utilizing BCD, which streamlines the addition and subtraction of time intervals in digital systems, which enhance processing efficiency and reducing the complexity of timekeeping operations. So these are the three conversions of between decimal and binary. First one is the systematic division method, which involves the conversion from decimal to a binary using repeated division by 2, which capture the remainders to construct binary equivalent in reverse order. So next one is power of 2 representation. So each binary correspond to a power of 2, which allow for straightforward calculations of decimal values by summing the contribution of each active bit. So last one is binary code decimal simplification, which enhances conversion accuracy by representing each decimal digit as a separate binary sequence, therefore minimizing error in digital computations. So last one is the role in debugging and critical applications. So the use of BCD in debugging ensures that each decimal digit is accurately represented, which reduces the computational errors and enhancing the reliability of outputs in high-stake applications like finance and healthcare.